So what I'm going to talk today about is the actual mining process, the extraction of minerals underground. We at Entech mainly deal with the phase up to development, like the feasibility study that was mentioned earlier today. And what we do is that we manage a lot of technical risk as far as being able to predict what's going to happen in the future. And discrete event simulation models does provide us an advantage as a consulting firm in actually modeling equipment behavior. Also, we're seeing an opportunity with corporate risk once the mine becomes in operation in relation to being able to simulate on a daily basis what we actually got to what we think we're going to move and actually calibrate it against the data that's served up underground. So in mining, we typically look at in terms of a mining life cycle, we go from discovery, which is the discovery of the deposit itself, exploration, scoping, PFS, where we are, feasibility and permitting, and the operations that shipping and that was mentioned before is after construction and during the actual ramp up of mining. It's important to note a lot of these capacity systems are defined at the beginning. To be able to make adjustments to these systems is costly on capex, and sometimes not achievable. So getting the design and the model right is an advantage, and I'm going to talk about that on the way through. So what's making it different today to as it was in the past is that we're getting a lot more data in a mining setting. Typically, mines are in hostile environments where you've got a lot of traffic, and you can imagine underground that comms would be very difficult to install, and they still are today. But what we're getting today is these new mines where they're installing fibre down the decline itself, which is the tunnel that accesses the ore. And what we're able to do is we're getting very good insights into equipment behaviour, such as the hauler system itself. The hauler system is the biggest emitter of carbon in the system. And when we talk about decarbonisation in 2050, there's a lot of emphasis on the hauler system and how to get the material to the surface. And typically in Australia, we run declines, which is like a spiral down to the ore body itself, which I'm going to talk about today. So I won't go much on about that. The other improvements is about maintenance needs and improving energy usage. And we've done various studies in regards to that. Knowing that we are probably on our first year of using JamSim in our organisation, and I can't think of many other mining consultancy firms that are using. I know there's one in Vancouver that's using the Rockwell product. So, mentioned before, our primary role is up to the construction phase and understanding the technical risk. We are becoming more involved with the corporate risks later during the cycle. We are building solutions on cloud now, and I'll show you some of the cloud solutions to actually serve up the findings. And we believe that JamSim and our expertise at Entech does provide us a competitive edge and simplifies the complexity of the mining phase itself, because typically mines are developed in phases. So simulation is the missing link for us in the industry. It's been missing for quite some time. Typically in mining, and has been done for many a year, is that we model the mine plan. So what we'll do is we'll generate a resource model from the geologist, and that's done by geostatistics, and then models are expressed in a sort of like a voxel, like Minecraft type setup. So me as an engineer, once I receive the model, it is a resource, and that resource, I will design and schedule the equipment to extract the minerals. And there's obviously what we call waste and ore in doing that. And what comes out of that is a financial model, so we can make a decision on whether we're going to go ahead with the project or not. And as we progress down the studies, the quality information improves, and there's a desire to get within 15%, which is all comes within the JORC code itself, the code that we operate under. What's been missing in our area is the way to simulate these models, and that's what JAMSIM's providing us. So once we get these designs and schedules and the equipment that we're going to use, we can use JAMSIM to simulate the actual mining process itself, and that includes the bogging of the ore and includes the haulage. And what that provides us is a way of calibrating and getting closer to the truth. And that's what we're discovering now, is that we're calibrating these event simulation models down to a level where we are able to predict what's going to happen within the day, a month, with a lot more accuracy. So I'm going to talk about a particular study I've done. I'm not able to disclose the client's name because they went into administration, and we used JAMSIM to get them out of administration with various other techniques as well, and in terms of bulking out the ore body. But what we decided initially to do is that if we're going to increase the capacity of the mine in terms of like get more material out of the hole, we have to simulate the capacity of the decline to achieve that. Obviously, there's more trucks required. So at that particular time, the client had 5 trucks and 3 bogging locations. So our objective is they're running at 1.5 to 1.6 million tonnes per annum, processing the ore, but we wanted to get up to 2.5 to make the mine work better. Higher cash flow, obviously, more product. So first of all, we need to construct a model. The geometry, as mentioned before, is given from the modeling phase. The system constraints are very important in a mining setting, like ventilation. Does need to be considered, and I can see us simulating ventilation as part of the JAMSIM model to get air down to the workings to extract the emissions and to provide a suitable working environment, and the fleet parameters themselves, which is provided from the OEM and the production systems that the mine has in play. So what we do is that we calibrate against the actual production profile, and I'll go through that calibration process and how we went with that, and we simulate, and we keep calibrating and simulating. Actually, calibrate should come after simulate. Looking at this, and then we simulate the objective and implement the plan. So here's what we're looking at. We're looking at up here is a detailed mine plan, which we create. The top part of it is what we've actually extracted, and I can actually show you what it looks like in proprietary software typically used in mining. As you can see, the truck enters here and goes down the decline, and you can see there's lots of opportunities for passing, and all them passing bays are like digitized into the JAMSIM model and simplified. And these colorful blocks here are the ore that's got to be mined, and they would have loadout bays that we would actually design as far as that process is concerned. You can see the stope here is half depleted, and as the mine progresses, that particular part of the ore body will be extracted. So what I do is I simplify it to a point where I'm able to understand where the passing locations are, and I put it into a JAMSIM model, which is Not as elegant as Harry's models, I must admit, with its shipping and stuff, but it does the job. And what I'm doing here is I'm actually, where is it? Simulating the trucks in the system. So what's happening here, we have particular bogging rates for the development, and that's the advancement of the decline as it goes down the mine. We have bogging rates for the ore extraction. And what we're doing with these particular signs is we're identifying the best, the stope that has the most material, and the truck will go towards that particular location once making these decisions. Now, these decision points are quite interesting in terms of mining because we haven't got a way of defining a decision matrix in mining, and this is providing that way of doing things, which will probably be able to optimize current operations with the use of the software. So if you go into real time here, what I'm doing is I'm pulling out 2.5, I'm processing 2.5 million tons, but only able to achieve 1.9. And that's simply because we don't have enough trucks or a congestion in the model that we're dealing with. And what I'm doing is I'm iterating this like a design of experiment a number of times. I think we did about 50 iterations for this one. And we started using distribution curves and stuff like that to model the bogging rate, but that's yet to come to fruition. But it gives you an understanding of what we're doing here as far as a Jamson user is concerned. So what does it mean? Typically in mining, if we wanted to work out the amount of trucks required for extraction, we would use averages and just simple algebra, and they're expressed in TKMs, tons per kilometre, and we would basically use Excel spreadsheets, and some sophisticated software in the market will actually provide them results. Simulation is not new to mining per se. There are products out there like Runge Haul Sim and various other products that are able to simulate haulage, but mainly in an open pit setting, not so common in an underground setting. And what makes an underground setting a lot more complex is the tunneling does create a lot of congestion. And also, as we get more sophisticated with decarbonisation, we've got to consider things like charging bays and the depletion of the battery as the mine, as the piece of equipment is moving. And to tell you the truth, it hasn't been solved in a haulage perspective. It has been partly solved in bogging, because in bogging you're actually on the flat. But with haulage, because you're taking such a large payload up the decline, there's a lot of energy spent. So what we're dealing with now, and I'm doing at the moment, is we're integrating conveyor systems into the mine. And we're integrating in some fashion, but mainly conveyors. And then you've got another problem. How does the haulage system interact with the conveyor system? Because you still need trucks to get to the crushing bay with the conveyor crusher before the material comes to the surface. So what we're trying to do here is we're in mining, we typically measure things in utilization and capacity, including the rehandle, which you try to minimize because that comes at an extra cost. So you can imagine once you get a truck to a point, there's another bogging location where we've got to load up the conveyor, or you direct tip into the bin. So what I'm doing in a decline type capacity is I'm trying to measure congestion to find out what that looks like, and minimizing it in a way where we can actually achieve them tons, and we're debottlenecking. In mining, we got a term called time usage model, which I think you probably use in other industries, but we've labeled it ourselves for our own purpose, and that provides utilization, availability, and breaks down all the different metrics for us. So the calibration step that we undertook is to provide us an understanding, is the model fit for purpose? So what we do is we simulate what's happening today, and we compare it against the production profile. A lot of this work was done in BI, just basically running JamSim to provide the entity log at all the locations for the truck and where it is. But the actual analysis was done in BI, but we're moving that to the cloud now. We're using tools like Grafana and Prometheus, get that right. But yeah, we're partnering with another firm called Arty, and I'll put that one out for you. If you want to get a really good understanding of the assets in a mine, you do need to have some sort of way of democratizing that production data, because it's all built on IoT now, and all these machines are spewing out lots of data, but we're not able to generalize it in a form where we can use it with purpose. And what we've done is we've partnered up with a company called Arty, which is ingesting JamSim models in the cloud today and providing insights using cloud technology. And I'll show you what that looks like. So this is a simple time utilization at different locations on the cloud, and this is just ingested the entity log from JamSim and all the various components. Compare that to BI, which is a lot more process intensive. If we have a look at the congestion map, this is how we're doing it in BI. And we're just selecting trucks. We actually get an understanding of where all these where the variability of congestion lies, because that's what we actually want to know, the variance rather than the mean. And we can focus on this east passing bay, and that may be a capital spend to put another passing bay up, but that wasn't required. There was no capex in this study. It was actually an opex. So I'll show you where the opex was spent. Okay, so once we've done that analysis, we're able to add trucks to the system, and we flex the production throughput at the plant. So what I'm doing is I'm actually pushing up the production rate at the bogging locations and let the processing plant process as much as it can. So at this 2.5 million tonnes per annum, I'm just saying you got 2.5 million tonnes per annum of ore available. How do you respond? The decline itself and the bogging locations, and have a look at all the queuing times at the loading bays, have a look at the passing bay congestion times and stuff like that. And what you see here is a time usage model, which we use in mining, and that's how we express our production. And we're able to build a theoretical time usage model, which is unique to mining. And I think it's only been done a few times, and where we're heading our consultancy into now. And these numbers are produced by JamSim and very easily passed on to the miner itself, mining operator. So here's 5 trucks. So what I did to solve this particular problem is I designed another loading bay into the, I decided where it was going to be and how it was going to be built. And because it was actually part of the production profile, there's no actual capex associated with that, because a passing bay, a loading bay will get developed regardless. So what it meant is just more equipment, more trucks and another bogger. And what that provides is a way, because these operator is using a contractor, mining contract called Burn Cut, it's just an OPEX spend to get that additional tonnage out. This is what the calibrated theoretical time usage model looks like for 4 loading bays. And as you can see, the congestion is increasing as we are progressing, as we are increasing the number of trucks. And if you go back to here, there's no advantage because we've managed to fill up to meet that 10.5 with the 8 trucks. So basically, that's where we want to be. So only a short little study. I hope I wasn't too brief in that. And like I did, one of the reasons why I want to came today, and thank you, Harry, for the invitation, is that we are constantly developing these models. And I've spoken to Tom in the past, and he's been great. But I think there's got to be a time where we're going to lack our own capacities to actually develop models. So I think there's a good opportunity at Entech to work with other like-minded companies to build models for miners. And where we provide the entry point is that we do the studies. Now, Entech is probably the largest underground mining studies in Australia, or probably make it the world. We're quite unique in that. That's all we do. We do some open pit work, and that's where we are going to open pit and working with major players like Rio in understanding their production better. But it's a unique opportunity at the moment in the mining industry as we are heading towards decarbonisation. The systems are going to get a lot more complex. You do need mining engineers to provide their models to you. The understanding of improving models is where Entech is. And probably over the last year, I've been just using JamSim to provide that capability. And I think we can say that we're successful now in doing that, and we're increasing the size of the business around that. That's about it. Thanks, Harry. And Mr. Bradley.
Yes, Mr. Bradley. Thank you very much, Craig. That was a very interesting talk. I would like to prompt people for questions. I've got a few questions, but
yeah, who go?
My question is, I see where you are using BI and or Microsoft BI and Arty. You mentioned that Arty was a little faster and that I think Microsoft BI was a little slower. I guess have you refined that that data visualization, that workflow, so that it's very fast and robust, or is that adequate for your need right now? I mean, are you generating a ton of data, or is it mainly using it for visualization?
Yeah. What I find with like if I'm doing a run, I find the JamSim stuff takes about 20 minutes. The conditioning of the data into MySQL to make it available to BI takes about 2 hours. Noting that limited to my own capability, I'm using Python to do that conditioning of data, so just hashing the data across. Why we decided to partner with Arty recently is that we see an opportunity to have the asset production data next to the simulation data, so we can cross-reference the simulation versus the actuals. And we decided to partner with Arty because they are providing asset management. And when they came to our office in Melbourne, I showed them what they were doing in simulation. So I said, if you can contextualize this data in a way where we can compare it against production, we've probably got a good business opportunity, and that's what's happened. Knowing that I come from a model-based system engineering background, which is quite unique. I used to work for Dassault Systems, and these way of doing things around calibration and simulation is practiced in other industries, particularly in aviation and NASA and stuff like that, space exploration, is that what Dassault systems will do is that they will model an aircraft and they will simulate it, and then then as the aircraft is put into production, it is not calibrated, but it is validated in once it goes into service. And there's a whole lot of technology that sits behind that, which is product lifecycle management and stuff like that, to know to be able to contextualize the asset as well. So what I'm saying is that our gravity towards ARDI was more around asset management than more than the simulation itself, knowing that there's going to be a future vision that we're going to be calibrating against the asset. And if we've got the asset contextualized in a way where AI can ingest it, and if we've got JAMSIM in a way where it's actually put through the same models where AI can ingest it, we can actually provide a better understanding of where the model needs to improve. Basically it. Does that make sense?
Yes, it does. Thank you very much. I see a question from Jason. What drove you to choose JAMSIM Pro over perhaps other software?
My own research in terms of software selection was limited to my own exposure to that market. I must admit, since choosing JAMSIM, I found a lot of other competitors. I didn't even know about AnyLogic at the time. And I'm glad I chose JAMSIM, because I think I would have been spinning my wheels for a lot longer. What actually got me onto JAMSIM was a paper that was written in New Zealand, I think, or I can't remember, Harry, at the time, but there was a paper written in the early 2000s where they used JAMSIM, the open source version, to actually do a hauler system. And I had a look at it and I thought, well, I don't want a solution that's in the can, because if I go and choose these traditional hauler simulation systems that are provided to the mining market, like HaulSim and all these other things, I'm going to be limited to its own configuration, what's in the can. I knew at that time I would be modeling emissions, I would be modeling energy, I would be modeling other systems that influence the mine, because we want to get right down to fuel calcs. That's where we want to be. So I chose JAMSIM at the time, and I'm happy I did too. And the other thing that made it an easier decision was the price point. AnyLogic would have been a no, I would guess, from our perspective. We don't get enough work to justify the costs for an expensive piece of kit, because it only gets used a few times a year. And I think that's common in consulting, is that you're dealing with lots of different software and it gets costly. So we chose JAMSIM because of the price and the ability to configure complex systems.
All right, wonderful.
Yeah.
Go ahead. Oh, we've got another question. Mark asked, are you running the JAMSIM model automatically on the cloud as part of a ETL pipeline with Power BI, or is it still manually run with a human in the loop?
That's a good question. We're currently engaged with a German IT company. She might share that with you, Harry, after we finish this today. We're actually defining what the cloud looks like. So we brought all our business partners into the room, and we're engaged with a high-end company to define what the cloud looks like, so we understand the investment that needs to be made, and knowing that we're probably going to just capex it and build it. We will go there. We know that. We want to pull the data. It's got to be on the cloud. It's not going to be on-prem. And ARDI's working with us to achieve that.
All right.
So we're not quite there yet. We're still in development. I reckon, first of all, we need the right opportunity. If we get the right player, like a like a big player, we'll definitely, we just got to have a plan. So here's the player, here's the opportunity, here's our capabilities, this is what we do. Once we get the opportunity, just make the spend.
All right.
Can I ask a question? Sorry, it's easier than typing it. Craig, for the BI, have you ever looked at Tableau versus Power BI?
No,
In
I
turn,
haven't.
yeah.
Yeah,
Uh,
go ahead.
oh, it's just I have a lot. Sort of in a previous life, I had a lot of experience with BI and SQL and speed, and we found that the Tableau extracts were a lot faster to store, like ingest your data into. And there might be other reasons for you to like ingest it into SQL and stuff. That makes a lot of sense. But there's also a way to ingest it into their extract, and those are really efficient for in terms of speed. I just was curious if you'd ever looked at it.
Yeah, for data ingestion, I'm looking at R now as a language. I was limited to
Yeah.
Python at the time, because of my own expertise. But recently, picked up R, and I find R you can do quite a bit, which you may do in SQL, and
Hmm.
it's a lot quicker.
Hmm.
Because at the end of the day, all you want is a flat table. Um, you just
Hmm.
want to condition the data so BI can have a look at it. You know what I mean? So
Uh-huh. Yeah.
I would expect R would be where it would go. Then we go into the cloud as well, and and R is easy to get access to. But yeah, I'm getting promising results out of R now.
Interesting.